So the change on the agenda, we're going to have Robert Beckett with Cisco on the services technical leader and talking about deploying IPv6 in Cisco labs. And let me find his presentation in here. There it is. Right as the hammering begins, right outside our door, we'll just pause on those. All right, and I leave it to you.
This is what I use?
You can advance that or just hit the space bar, whichever works.
Okay.
I'm going to grab Joe's drink. I don't think
Hi, everybody. My name is Robert Beckett. I'm a services technical leader at Cisco Systems, work in the TAC, on the TAC escalation team. Been there about 16 years. And I wanted to give what I would consider a fairly simple talk on deploying IPv6 in labs. I won't be talking about anything terribly fancy like extension headers or NAT 464 or anything like that. So hopefully you can keep it simple going into lunch here. Yeah, let's move on here. So when it comes to deploying IPv6 in labs, especially if you have labs as large as we do, with thousands and thousands of devices in them, you may say to yourself, this is a very daunting task, because you may think, well, I got to put an IPv6 address on everything, just everything, whether it's a network backbone with the routers and switches. I'm thinking about all the terminal servers, being able to do Telnet, SSH, VNC, all those via IPv6. All my file servers, all the services that the lab use, whether it's DNS, DHCP, NTP, SNMP, all the NMS systems, even the IP phones, the wireless. And if I'm really thinking about everything, I could be thinking about the power management, room access, surveillance, the thermostats, fire detectors, even lights, as we've seen. And at that point, we're really talking about the Internet of Things, or even the Internet of everything. And you got to step back and say, well, this is not what we really need to get a lab going and make it useful for doing IPv6. All we really need is to get the network backbone up and running, so that means the routers and the switches, particularly the layer 3 switches, the terminal servers, so that we can do Telnet, SSH, and probably the file servers. If you want to do some of the services such as DNS, that's up to you. For us, since we're doing a lot of router and switch type testing, those aren't necessarily required. It just depends on what kind of testing you do. So the important goals then are to enable IPv6 connectivity within the lab. This is something that probably people have been doing for years and didn't really need much help from the lab maintainers. But we also wanted to go a step further to enable IPv6 connectivity between labs, because we have lots of labs all around the world. And we wanted to enable IPv6 connectivity to the internet where it's needed. And with the overall goal that whatever needs IPv6 or whatever wants IPv6, that it's there and they can enable it and be ready to go. So by working on the routers and switches, we're really laying the groundwork for the future. We can bring in the other things so that we get to the eventual goal of the Internet of Things piece by piece and achieve that later. This is a quick look at a map of our labs, and major labs, I should say. There's 9 labs here, San Jose and Raleigh, North Carolina, and places like that. We have a lot more labs than this, but just a quick overview. And to kind of reiterate a point I made earlier, the overall goal is combine the labs into one unified, scaled virtual system, the common architecture and processes. You could call it a cloud, if you will, or even, if you want to get nutty, you could call it lab as a service. So more immediate goals for us, Cisco services, is to be able to support more TAC IPv6 cases, not just quantity, but also the different kinds of cases that are coming in more and more. That's mostly recreates, but it's also taking on more dimensions, more kinds of cases. Another relatively immediately goal was to be ready for World IPv6 launch day. That's not only for us to be able to say we're IPv6 ready, but to be able to support the company as a whole once the attention is out there and there's presumably more cases coming in that we need to handle IPv6. Also a goal for us to have greater internet addressability in the lieu of very limited public IPv4 address space. What do I mean by this? I mean that up until IPv6, we had very little publicly addressable IPv4 address space in our labs, both kind of on purpose and as it's kind of a limitation. On purpose because we didn't want a whole lot of devices on the internet that people could go probing. And on the other hand, it's kind of a drawback for us because there are cases where we need a device to actually reach out on the internet and do something. So we have very little address space there, and so bringing in IPv6 gives us an opportunity to try and rectify that. Also, we have a need to be able to give ourselves better addressability in the lieu of limited RFC 1918 address space. And what does that mean? That means we, I think like most enterprises, we use RFC 1918 address space internally, and we use virtually all of it. And to the point where it's actually a limited resource for us now. So some labs have had to go and kind of steal address space from elsewhere. So we have one lab, for instance, that's addressed from 14, the 14 network. And that means they can't talk to anybody, not even anything inside Cisco. It's effectively an air-gapped lab, and that's an awfully big problem for us trying to set up labs across labs. So this was an opportunity for us to use IPv6 to help solve that problem. So as far as topologies, there's an awful lot of possibilities, and in the end, what we went with was kind of decided for us in terms of what Cisco IT presented to us, and our desire to sort of keep things simple to help get it deployed. So obviously we wanted to stick with dual stack. We're going to be doing IPv4 recreates for years and years and decades and decades. We have some labs that have the ability to connect to, have a direct connect to IPv6 backbone, and we have other labs that don't, unfortunately. We unfortunately do not have IPv6 on our entire corporate backbone. So there are labs that in order to get connected need some kind of tunnel. The kind of tunnel that IT offered us was a simple 6 and 4, very easy to configure. Also, we have all the different routing protocols to choose from, whether it's RIP or EIGRP, OSPF, ISIS. And if we were really trying to go super optimized, we were thinking like an ISP, for instance, we might go with ISIS because it's truly integrated. But for labs, it's really not important. At the most, we're going to have dozens of neighbors to worry about and maybe hundreds of subnets at the worst case. And So we might, for IPv4, internally we used EIGRP, but since IT was offering these 6 and 4 tunnels with just simple RIP v6 on it, we went with that, and that kept things simple. So here, the first bullet I list, we got a /56 for, and I'm talking about a particular lab, in this case San Jose got a /56. Other labs, depending on their size, got a, some of the smaller ones might get a /64 for the single subnet, some might get a /60, one of the bigger ones got a /55. In terms, if we were designing this network ourselves, we'd be having to decide, well, are we going to do full mesh tunnels between all the different labs, or are we going to home all the tunnels to a single router? In our case, it was kind of, Cisco IT said, here's your endpoint, and they took care of that for us. So nothing stunning as far as an architecture to lay out here for you. Inside the lab, given the fact that our lab in San Jose has been there for close to 20 years, it's kind of grown in various ways, so it's not a real strict hierarchy of things. So it's a combination of a main gateway, sometimes some intermediate gateways, sometimes some layer 3 switches, sometimes layer 2 switches. So I'll show you some examples of how to configure those later on here. Obviously, we want to route IPv6 on routers and layer 3 switches to as far to the full extent of the lab that we can. Obviously, we don't need to worry about layer 2 unless we want to try and manage them as IPv6 hosts. That wasn't a concern of ours right now, but that obviously will be later on. And we'll move on here, okay? So the main gateway for us in San Jose is a Cat6K. And again, it's a simple 6 and 4 tunnel that it connects into the Cisco IT backbone. There's the, it has no IPv4 address. It does have the a /64 in a sense used up right away for the connectivity, and it's a simple tunnel mode IPv6 IP. We have the tunnel home to a loopback because our gateway is dual homed. So in order to take advantage of that, we keep that tunnel home to a loopback so that we take advantage of the uplink redundancy. Continuing on, there's basically two different ways that downstream devices in the lab can connect to this main gateway. First example is VLAN 11 here, where we're connecting to a subnet where a bunch of intermediate routers connect. And we just kept the IPv6 RIP to go along there, and made sure to originate the default route so that everybody could connect back. And we'll see an example of an intermediate gateway configuration coming up here. The next one, the VLAN 240 here, is an example of the configuration needed for connecting either directly to a device or through a layer 2 switch where a bunch of devices could connect. Very simple. It's just doing slack. And then at the bottom here we have our default route pointing out to the tunnel 0 and having to enable a global RIP v6. On the intermediate lab gateway, we have it's a similar type thing where we're going to use the uplink interface is going to be configured with RIP v6, carry those routes from the lab, and enable connectivity. The downstream interface here happens to be a sub interface, so it's one of a group of VLANs that are going down to a layer 2 switch that'll eventually hook into hosts. In this particular case, it hooks into a VMware system. And again, it's just a simple IPv6 address config, so it's just a simple Slack config. So, and then finally, when you get to the end device, and again, I have to assume iOS here, we have obviously a lot of different devices, they all have different ways, but in terms of iOS, if we want to go the simple route, we don't care what kind of address we get, we just use Slack or DHCP. That'll give us the IP address, the subnet, the gateway, the DNS. It's real simple IPv6 address autoconfig on the interface. If we want to go static, we got to do all of that ourselves. Put in the address, and you see here that if you're going to do it yourself, you're going to keep it simple. Rather than trying to come up with an entire 128-bit address like DHCP is going to hand you, we're going to take, know what that 64-bit subnet is, and just pop on, in this case here, 88, a simple address identifier that helps us keep it short. We'll have a default route, we'll have a name server, and we'll have the domain name configured. So let me come back here real quick. I don't think I'll have time for it, but I have slides at the end, backup slides, that talks about the different kinds of DHCP that you can do, whether it's plain and simple Slack that you get no DNS, or the next one being DHCP stateless, and finally full-on DHCP stateful. So I have examples of how to configure those in detail and tells you how those work. So some of the challenges of deploying IPv6. I think this is the real meat of this talk here. You know, the lab has been around for a long time. It's very large. We have limited manpower. You know, we have a mandate to do IPv6, but not a whole lot of man hours to do it. So we had to, you know, prioritize what it was we really wanted to do IPv6, get it going. One of the issues that I mentioned before is that, you know, our IT backbone itself is not entirely IPv6. So labs like the one in San Jose had to rely on a tunnel to get to IPv6 connectivity. And some of the more mundane things that had to be done, some hardware had to be upgraded. In our case, not a whole lot. In fact, I can't think of any that actually did need upgrading. But we did have a number of cases where software had to be upgraded, whether it was, you know, it's running an old version that didn't necessarily support IPv6, or it was running a subset of iOS that didn't support IPv6. We, unfortunately, we had in our IP base images years ago, they did not support IPv6. And that seemed really stupid, honestly, to a lot of us, and that has been rectified so that all IP base images now do support IPv6. So there were a number of cases where we had to upgrade just because of that issue. And interesting enough for me, I would have thought we would have had EIGRP v6 on the Cat6K in relatively old code. You know, maybe not ancient code, but at least relatively old. And I was, to my surprise, I discovered that EIGRP v6 is not supported until 12.2.33 SXI. So unfortunately, these are the kinds of surprises we ran into trying to get the lab going for IPv6. Also, super mundane, labeling. IPv6 addresses are longer, And the lab guys really like to label the equipment with the subnets that they support. And our switches are getting denser and denser with ports. I know that in the racks I maintain myself, I have switches in there that have no room for any labeling whatsoever. So that's bad on me. The lab guys have actually explicitly chosen switches that have fewer ports so they have room for labeling. But they still have to adjust for IPv6. Okay, what changed IPv4 versus IPv6? So one nice thing in IPv6, the subnet size worries are gone. In IPv4, you always had to say, well, how big of a subnet do you really need for this amount of equipment? And then we also gave ourselves a problem of, well, how do we divide that subnet into addresses that are statically configured versus ones that are configured via DHCP? With IPv6, the subnet's so huge that no one cares. And there's so little chance of a address collision in DHCP versus IP versus static configuration, because if you're going to do static, you're going to keep it simple with the .1 and the .2, .88 versus DHCP, which is going to give you a full EUI 64 on Ethernet. So there's almost no chance of collisions there. Another thought, some of our switches support broadcast suppression. Well, IPv6 doesn't have broadcasts, but you still need multicast suppression if you like to have that kind of feature on your switches. And another mundane feature is management. If you have a lab as large as we do, it is important to keep track of the subnets that are assigned. And we actually have two tools for doing that. One's kind of an internal tool, and I apologize here, I used an internal acronym called CALO. It stands for Customer Advocacy Lab Operations. That's the team that works on lab operations. So they have a tool called Omni Tool that does subnet management, and IT has one that's just called address management. Those have to be updated for IPv6. So in the future, we want to do more IPv6. Right now, as I mentioned, we've pretty much covered the routers and the layer 3 switches, trying to make it so that whatever wants to be on IPv6 can. In the future, we try and be more proactive about assigning IPv6 addresses and makes it easier to manage them. Also, we probably want to move from the very simple SLAC that we have right now to either stateless DHCP v6, which I kind of like because it's still simple, and if you're concerned about addresses, and some labs are, then we may want to go to stateful DHCP v6. Also, I mentioned we have a lab with non-routable IP address space, completely non-routable, that 14 network. Though that lab may want to, in the future, just move away from that altogether and just say, we're going to use IPv6 only. And also, we do have a DMZ network that has more direct connection to the internet. We don't have IPv6 on that today, but that's something we'd like to do. Here I have got just a couple of extra resources. We have a Cisco support community for IPv6, including the IPv6 transitions, and also the main IPv6 page on cisco.com. And I think, yeah, that's pretty much it. As I mentioned, the slides after this, yeah, I'm running out of time, so the slides after this go into router discovery and how we can configure SLAC versus DHCP stateless and DHCP stateful. So have a look through those. Gives you the overview of the technology and how to configure it. So I think that's it. Any questions? Okay, I guess that's it.